or put them on silent, okay? Right now.
Can't hear you, my phone's
I don't want Steve interrupted with a cell phone ring, all right?
Screw that guy.
I'm Bev Trinowski. I'm the vice president of the Ishpeming Rock and Mineral Club. This is Kirsten Mackey. She's the president. She doesn't have a voice tonight, so I'm gonna start you out because she needs to rest her voice, okay? So anyway, welcome. Thank you for being here. We really appreciate it. We're going to start off tonight with a speaker, but I want to do a couple announcements first. Those of you that are members of the Ishpeming Rock and Mineral Club, September 10th, mark your calendar. Scott Markert is going to be hosting a barbecue at his house on the Dead River Basin. We're going to get Walworth brats and hot dogs. From the club is going to furnish that, and everybody else bring a dish to pass. So that is just going to be a fun event for our members to come. If you're a non-member and you're going to be in town, let me know. I'll add you to the list. So
Join the club.
Join the club. There you go. There you go. So that's just going to be a fun event because Scott wants to do something nice for the club and that kind of thing. Scott and his family founded the Ishpeming Rock and Mineral Club. Scott and his brother were actually the first two members. They started their club in their treehouse. And then their parents thought, I think these kids are into, and they used to ask their parents to take them to local mines to collect. And the parents thought, I think these kids are onto something, and started the Ishpeming Rock and Mineral Club and registered it with the Midwest Federation. So Scott has been donating a lot of his collection to us for silent auction, and some of these live auctions are from Scott. So September 16th, those Ishpeming Rock and Mineral Club members that helped yesterday, today, and tomorrow, we're going to be paying your way into a field trip with the Copper Country Club. We're going to pay the fee to get into the field trip only. We're not paying for your transportation up to the Keweenaw and all that, but we will pay your way because you helped. So it will be September 16th. We are not sure the mine yet, okay? Because there's some issues going on with some of these owners are crushing on Saturdays coming up in September, doing a lot of crushing. So we'll announce to you via email, our club email, when we send out emails, we'll let you know where that's at, and we'll ask you to let us know if you're coming or not. But we will pay your way. That is our quote grunt trip. That is our way of saying thank you for helping with the show. And the field trips are on the show. So I just wanted to let you know about those. Other than that, I'm going to introduce our speaker.
Bev, would you announce, did you find an owner for that bag of purchases? Someone like.
No, what bag of purchases? Is that white bag right there?
I think so. Somebody had left that at a table. I don't know what's in there, but.
Is this it?
That's it, I think. Yep.
It's a bag of purchases that we don't know who it belongs to?
Right.
Okay. What I have to do is, if the person isn't here tonight, Rebecca, somebody may show up at Cliff Shaft and ask that they left their bag of purchases at the show. So FYI, just so you know, we have it. The club has it.
I'm
Okay.
incognito, but this is Rebecca from Cliff Shaft.
Okay. So we'll figure it out. Glad we'll figure it out. Somebody will claim it. If they don't, we'll put it on the next silent auction table at the club meeting. Okay. All right. So the speaker we have tonight wrote this wonderful book, which I put in my car already. Who has a Jack? Hold yours up. Where's Jack? Okay, he wrote a book called read the title, Jack. No, I want him to read the full title of There you go. That
Sounds like a paper title.
Steve wrote this book. Steve Baumann wrote this book, and he's going to talk about his book and about the roadside geology of Upper Michigan tonight. So let's give him a hand of welcome.
A lot more people here than last year. So I was also told I would have 45 minutes. See how
We're
that
easy.
goes. So I got a, timing here, just to be sure. Okay, there we go. Oh, never mind.
I'll just watch.
Don't just watch for me. I don't know what I'm doing. Okay, last year, does anyone remember the one from last year? Well, this is a different presentation. And I decided to focus on the Mid-Continent Rift this time. I was going to do the Niagara Fault Zone, and not as in Niagara Falls, as in Niagara, town of Wisconsin. And how it's a myth. People don't like me saying that, but I don't have enough evidence for that yet. So we're going to go with this. Now, I know most of you probably know what a rift, and this is going to be a geology talk. So you can associate it with the collect things and stuff like that. You can just read that if you want. Geology, a rift is an area of extension where faulting has allowed for crustal thinning and created through volcanism. And the Mid-Continent Rift, a lot of people think it's what we call an allocogen. When these things form, they tend to form, this is just something I pulled off geology.com. They tend to form these triple junctions, and eventually one of these fails, and that becomes your allocogen. The Mid-Continent Rift is not a failed, these are common. These are so common. It's an entire failed rift system as far as we know. There's another hypothesis that a paleocontinent called Amazonia may have broken off, but yeah, so it's that part right there. Allocogens in nature. Me and my wife, with a friend last year, around this time we were getting on the plane, went to Greenland. So the Gardar Rift is an allocogen in Greenland. Sorry, I had to stick some, I had to, just had to. Now, you look at this, you see ripples, and this is sandstone. It looks a lot like something else. It looks a lot like sandstones out here, doesn't it? Mm-hmm. Okay, now it's not from the same rift. It's not part, it's a little older by about 100 million years, I think. But it's a failed arm of an older rift. See, and this is Greenland. This isn't out here. And yeah, there's a nice shot here. You can see there's about the contact. This is a sandstone, and this is basalt, just like you would get. Out here, though, it alternates between Eriksfjord sandstone and this basalt, sandstone basalt. Here, you know, you get the thick basalts, and then you kind of just go into the sedimentary rocks. These waterfalls there. Here's me on the sandstone. This is a conglomerate within. Now, you guys have conglomerates here, like the aloes within the lava units, but this is so different. It looks so different. This is can't really tell us why you got to get up and look. This right about here is a contact. This is sandstone, and this is rhyolite on top. This was a surface flow. You can kind of tell by the weathering, and this has what we call phenocryst in it, little inclusions of feldspar, and this is the sandstone. So you got to get up there and look. All right, now I'm going to just talk about rifts in general. Cross section. This is from the book. I cite things that aren't mine. If you don't see a citation, it's mine. Now, basically, this is just a cross-section through the earth, and you get magma rising up through the crust, and then eventually, sorry, my brain just failed. The magma rises up as these two parts move away from one another of a continent. This is on continent. This can happen in the ocean as well. Doesn't really matter. And then you get igneous rock, usually mafic, like basalt, filling it in. And then here you get grabens forming, you get faults, and these continue to move apart. This is just a general idea of how a rift forms. Now, the Mid-Continent Rift stopped right in here. But usually they continue like the Atlantic Ocean, and then you get passive margin sediments, and then they continue off and you get a big ocean. And eventually that ocean basin will close. It's not an exact like heartbeat type thing. It's what we call a Wilson cycle. It'll open and it'll close, and everything's not going to line. We're not going to get a new Pangea like we had 300. It'll be different. It's not going to be exactly the same. The extent of the Mid-Continent Rift, MCR. Here's Lake Superior. This is a paleo reconstruction. Laurentia is the name we've given for paleo North America. You can see Greenland. There's Amazonia. Oh wait, no, where is it? Oh yeah, they're both Amazonia, moving towards and then away. Yeah, there it is, towards and then away. And some people think this was the successful part of the Mid-Continent Rift, but we really don't know, because at about the same time something else was coming in. It's really hard to get this out of the way fast enough to get what was coming in, but I don't know, maybe it works. It's a lot like the East African Rift. Most of us think it is an analog for that. There's some people who don't, but the co-author, or Lisa, who authored the book with me, she did paleomagnetism on the rift, and that was her dissertation, and she thinks it is like the East African rift. And the mid-continent rift is about that long. If you go from here up down through here, you can see that's Oklahoma, that's Alabama. So this thing was massive. So the continent ended right about here at the time. See the Grenville front? That's what came in as Amazonia was supposedly trying to get out of the way. So how that works, I mean, I know tectonics, I still can't figure it out. So, but it's not my hypothesis, so. Development of the MCR. We have, a lot of times when we look at these things, we think in terms of physiographic and geologic, or geomorphic and tectonic. This is a physiographic map of North America from USGS, and you can barely see, I can't read that, that's the number of the publication. Now you look at this and you see coastal plain, interior lowlands, Canadian Shield. These are physiographic divisions. What that means is they're based off basically topography and landscape and stuff like that. Then we get into geologic, and this is a great paper. This is back in 2007, and we still use this thing. You see a bigger mess. It's not as simple. You have the Superior Craton, Wyoming Craton, you get Slave Cratons up here, and then you see all these other little colors through here. Talk a little bit about those as we go along. How am I doing on time? I don't know. I don't care.
Don't sweat
Don't
it.
yell at me.
Don't sweat it. We enjoy listening.
Okay.
Bunch of rock nerds.
Okay. I got to give you a brief history of Laurentia first in order to understand it. About 2.5 billion years ago, now this is from that other paper. If you see this, it's from that paper. Now these are all these little cratons floating around exactly where they were. Who knows? I've been trying to get people to do dissertations on the Huronian, what we have here, which is, we do have Huronian, I'll get into it later. There are Huronian equivalents in the UP, but most of it's in Ontario. We don't exactly know where these were. Like I said, I've been trying to get people to do reconstructions, and nobody, when they all want to play with the mid-continental rift, well, I can see why. But so basically what you had is these were different places. The funny thing is, when the mid-continent rifts formed 2.5 billion years ago, the mid-continent rift's about 1 billion years old, so about 1.5 billion years before that, there was a successful rift right here. We rifted away. Some people think it was a Wyoming craton that split off. Some think it was the Vol of South Africa, one or the other. I don't know, but it's really hard to swing a piece of craton like that in tectonics. Because tectonics is, I'm going to get a little bit into it, but there's a lot of maths, and yeah, it's a lot like structural geology, which is more like engineering. And this is my main thing. I do structural geology. But, okay, so before the mid-continent rift, don't worry about that. I put that up there for a reason and I forgot. Okay, this is the Huronian supergroup, lithologic package, which means it's a package of rocks. And the Lorraine Formation, that pudding stone is right here. There's a piece of it in front of the Siemens Mineral Museum. I donated that and went up north and got it. But you see it's a whole thick package here. And this is how we know or suspect plate tectonics actually hasn't been in operation for 4.5 billion years. This is like the biggest question of the 21st century. Only the real old timers say it is. It has been, but we know it hasn't. Just like the big question of the 20th century was, believe it or not, the early 20th century, were granites igneous or metamorphic? And this is the publication that settled that in 1958. I have an actual copy of it. So don't fall out. So yeah, that's not for sale. So this looks like a passive margin. Passive margins form after a rift forms and sediments pour out off the continent. This would be like the Gulf of Mexico or off the coast of the Carolinas and the Atlantic. Not really Florida. Florida's just a bunch of dead things with some sand on top. So I study the Precambrian, by the way, as you can tell, so I make fun of stuff. This here are the intrusions that cross-cut the whole thing, Nipissing, and those are firmly dated. Here's the rift volcanics at the bottom of the Huronium, also dated, and we now have what we call detrital dates from all this sedimentary stuff, so we have a pretty good estimate of the age of this thing, or how long it took. And this also has glacial deposits in it, 2.5 billion years ago. Now, if you go online and you type in Huronian glaciation, you see a lot of videos on YouTube, even by people who should know better, like PBS, that this is not, this whole package is about 300 million years. But it's not 300 million years of glaciation. These green units are the glacial units. The rest of these are normal passive margin sediments. So we had several glacial advances, and here in the UP we have this. We have the Marquette Range group, which is obviously out here, Wee Wee Slate, Kona, that's that beautiful of the siliceous carbonate. And we have, is that Enchantment Lake, I think is this one, right here. Sometimes I don't remember all the names. And those all probably correlate with the Gauganda, the basal Gauganda Coleman member, which is actually a very complex unit of glacial deposits. And then over more to the west, we have the Menominee group, where we have the Ramville, the Sturgeon, and the Fern Creek, which is glacial. And these all correlate only to the upper part. So the UP was mostly dry land for the most part, while most of the Huronium in Ontario was getting deposited. So we have big erosional unconformity. This is just a graphic cross-section of the relationships with the unconformities. The cobalt, this, you see A to A prime, but then it's A to A prime, so I flipped it, I'm sorry. These are in the book. Yeah, these are in the book. So, yeah, this is just to show you how the deposits form. And there's that pudding stone, and oh, it was the calco clay group, that's what it was. And here's a Sturgeon, Mesnard, and there's the Fern Creek, Enchantment, Gauganda. So it shows a completely normal passive margin sequence. I can't think of a better way to interpret it. Now, as we move on, we get about 2 billion years, or 1.8 billion actually. This is what's called the Pembine-Wausau terrain. This is an accretion of an island arc. And right here is where the Niagara Fault Zone is mapped, but if anybody can find it, I'll give you $1,000. I have been out there, I've looked at logs, I can't find this thing. The rocks supposedly go right up to where it's mapped, are not deformed. They just bank right up to it. There's something called Pompelli's rule that's expressed in some of the, there's a lot of folding, but I haven't seen it. Anyway, I think it's like an Iceland type thing, formed like Iceland and then accreted later, but we're still working on that. And this marsh field, that would eventually bump into that. But see, you already have the Huronian, and also something else happened at 1.85 billion years ago, right about there, Sudbury impact, right there. Kicked all that stuff. I have a piece of ejecta from Thunder Bay all the way over here. And it's, seriously, man, it's a crossing, it's about a foot thick, so.
Just up the road.
Oh, yeah,
Exposure of it.
yeah. I try not to tell, it's not in the book, I didn't put it in the book or anything, just trying to
Roadside.
keep that one out. This here is kind of the geologic provinces, mainly Superior. And basically North America, from modern direction, obviously continents move. North is to the top, basically up until the end of the Precambrian, just built from north to south with a couple of additions from west to east. So there's our Pembine-Wausau, I believe this is the Yatvi, this is the Matzaw, and this is the Grenville here, and that's that thing. The Grenville's a long orogeny, I think it's like 200 million. There's actually a bunch of other ones. Like we had a lot of little, we're starting to figure that one out too. But see, here's the first Grenville that plowed into North America before the rest of it did. And I don't know how you're going to get a big continent out of the way before you get that to move in. But it's real quick. Brief discussion of the mechanics, plate tectonics. You have three main driving forces, something we call ridge push, mantle convection, and slab pull. Now, if I ask the vast majority of people which one of these is the most dominant, they're going to say this, mantle convection, or ridge push, because that's what you always see. This is from National Geographic. Every video, you see this, and you see the core just bubbling up. By the way, the mantle is a solid. Just tell you that right now. It's not a liquid. And you see this, and then it pushes out of the way, and that is inaccurate. It doesn't, most of these are probably shallow. They don't even generate at the core. Hotspots like Hawaii probably do. Yellowstone, probably, but not here. The rocks aren't that mafic. So they probably, because in order to melt rock, you can heat it, but the mantle, like I said, is a solid. We know that because seismic S waves go right through it. An S wave is a shear wave. You cannot shear a liquid or a gas. So the fact that they penetrate it and don't disappear and don't get they get deflected, but not. They go through it. You can pick them up. So we know it's a solid. It's just a very plastic solid. So the only liquid parts to this planet are the oceans and the outer core. Everything else is solid. Oh, and the little melts that we get along ridges and volcanoes and stuff like that. But what happens here is that you get thinning of the crust. You get the mantle here, and there's a couple ways you can melt rock that don't really involve heating. You can relieve the pressure and add water, and that lowers the melting curve. So, and this is just a subduction here, subduction plate, showing you some earthquakes. You notice earthquakes pretty much don't go any deeper than this. That's how we know the mantle's plastic, and the plate descending slab starts to become plastic. The rigidity is almost gone. See, that's another thing about plate tectonics. You have plate tectonics, you have to have plates, and they have to be rigid. So you can't, that's why Venus doesn't have plate tectonics. Slab pull is the dominant force probably. They're all very important, but slab pull is probably the reason why this process goes on. And like I said, we don't really know when it started. 3.2 billion, 2.5 billion, maybe transition zone. There's even some people who think it started and stopped and started just because we had supercontinents, but that doesn't mean anything. The oceans can still rift and subduct, ocean plates don't preserve. So this is Christopher, how do you pronounce his last name? Scotzi. He said I could use any of his videos that I wanted. I think this, oh no, I skipped it. No, that's all right, we'll get into it. There's something about plate tectonics too, I just want to talk real quick. Everybody just shows continents sliding around the planet, just going every which way. Oh, Pangea assembled, oh, it broke up. But it actually follows a predictable pattern. Something called Euler poles, and the plates themselves, you got the globe, Earth rotates about its axis, spins about its axis. These things have axes too. They're not aligned with the North Pole. They're aligned, we have about 12 large plates. And this guy shows the concept in general. You need a minimum of 3 plates to really have plate tectonics. So he has 3 here. Earth has about 12 big ones. 1 plate is not plate tectonics. So see, that's the north, like the axis of Earth. There's equator, lines of latitude, and here's just some random plates put on here. Now they're going to start moving. You see, this would be your mid-ocean ridge. This would be a subduction zone, and these are what we call transform boundaries. And as you see, these plates are rotating around what we call an Euler pole, which is right about here. So these do move in predictable manners. This isn't, they just don't randomly move. But the predictability only goes so far. There's other things that can happen. A hotspot can form, a plate can get subducted too fast. I know this is going to sound weird, but you can subduct rift zones. And that's what's actually going on the west coast of the United States right now. Whether or not it'll move inland, because the basin and range in southwestern United States is actually, continents trying to rift there. Whether it'll succeed or not, I don't know. But you can kind of see it here too. You just see it, and you see, if you look at the new ocean crust forming, that's the red, you can see the Euler pole for Africa is up here. For North America, it's in Greenland. Now they change a little bit because you have microplates and things like that. So it's not perfect, but I mean, you can tell, I mean, this is totally predictable. It's not something you can't really predict. And based off spreading rates, active spreading rates, this should continue, but it probably won't. It'll probably close. But, you know, okay, here we go. Now you all should know this. Sorry, I babbled too long there. Anybody's asleep? No, not yet. Okay. Lake Superior. I think you all know what this is. We'll talk a little bit about my favorite place of the UP, up here on the Keweenaw, little favorite part. Now you see here, these are the sedimentary or metasedimentary rocks. The Sibley group is actually older than all of this. It's down here, and it's this little part. Now, I talked about allocogens. A lot of people think this might have been the failed part of the rift, that allocogen, but there's nothing there to indicate that. So, I don't know. But this is how the whole thing looks. So we're right up here right now. And then all these others are volcanics. And here's the Keweenaw Fault. That's a very prominent feature and a very significant one. This is the Douglas Fault on the other side. And this, I'm currently working on redefining the Frida Formation. It can be divided into members. And the Douglas Fault does not go this way. It's another one. You can actually solve this entire structure area with just folds. And since it's softer sandstone, it's probably folded and didn't fault. The Douglas Fault is a real fault. It just doesn't go where it's been traditionally mapped. It can't. The lithology of the rocks are the same as at Montreal Falls. It's got to be syncline. So yeah, we don't know everything, and stuff changes. And, you know, a lip is just a large igneous province. Basically, the mid-continent rift, when it failed, people start, you know, it's a large igneous province. It's anything with a large body of igneous rock. So that's all that is. And this is actual, by Stein, mostly Stein. And this is just another cross section. This is just basically how it formed the mid-continent rift specifically. This isn't a generic thing. The greens are your volcanics. And then eventually you get your sediments. This would be the stuff like the Copper Harbor conglomerate, the Nonsuch, the Frida, the Jacobsville. That's all this. And then wherever it stopped, for whatever reason, shortly after that, compression began from the sides. And that's how you get the Keweenaw Fault and Douglas Fault and all those other. Those were probably normal faults to begin with. They were reactivated and extended during compression, which is probably from the Grenville creating. So yeah, that's basically it. That's basically the situation today. This would be your mantle. This is your pre-existing crust. So yeah. Just quick stratigraphy, mid-continent rift. This is in the book. Basically, in the UP, we have this basal quartzite. This would have been the sandstone that started to fill as the rift started to form. Then we started getting the volcanics, Portage Lake volcanics, Porcupine volcanics, Porcupine Mountain, obviously. This is actually a complex series of basalts and rhyolites. And there's a couple andesites too. And then we started getting the clastics, rifting Stott. And we still had a couple gas, Copper Harbor, Nonsuch, Frida, Jacobsville group. So this red here is basically part of the mid-continent rift that's exposed at the surface. The green is just outside of the UP. The yellow are the older stuff, the stuff we're sitting on, you know, older than mid-continent rift. And this is all the Phanerozoic, you know, Paleozoic, the Cenozoic stuff that I don't care about. So the book does cover some of this, but if you get the book, remember, I can only put sites in where the rocks are exposed. And those of you that drive over here know pretty much what are you at bedrock wise. You got the falls, and you've got some Devonian here, and a couple little outliers, and that's it. You don't have anything like you have over here, you know. So the book is clustered over here, just by default of the geology, because it's not a glacial geology book; it's a bedrock geology book. So yeah, so beware of that. And this shows metamorphic nodes. About where? Right there. There's a Marquette syncline, and the center of these things is most high metamorphism, and from there, metamorphism becomes less until you get into the light green, which is low chlorite. Certain minerals and rocks get metamorphosed, and we use mudstones for this because they have a whole bunch of junk in them. And as stuff gets metamorphosed, minerals will form that weren't there before, just from the heat and pressure. And that's what the chlorite, and these are the main minerals in the UP. There are different ones that will do this. You see garnet, and there's actually garnet at, where's the pier, or, it's in the PV node. Oh, hi. Oh, man. My head is. I've only been there 500 times. Piers Gorge, thank you.
Yeah.
Yes, thank you. You can actually see little garnets in some of the slates there and stuff. And there's actually a bit of Piers Gorge too, where there's some of that stuff is actually metasedimentary. It can be hard to tell. This whole thing, when you get down here, the Pinokian rocks, it can be really hard to tell because you'll have igneous rocks, which are crystal, and then you'll have sedimentary rocks, which are directly derived from those crystalline rocks. So the color's the same, the mineralogy's the same. You've got to really look at them to differentiate them. Like me and Sarah went to the dam on the Menominee River because that's a series of sedimentary, igneous, sedimentary, but it's all mapped as igneous. So you really got to take a close look at these to understand and step back. And that's another reason why I don't think the Niagara Fault Zone is here, because this is all mapped as igneous south, and it's mapped as Michigami north of it, which is slate and graywacky. And it just seems like it's a convenience, but there's a lot of tight folds in here, but it seems like, because you got metasedimentary rocks in here too. I just think it was a fault of convenience, is really what it looks like. Doesn't mean that you didn't have an island complex ram into the continent. It just means it was a soft collision. Okay, so mid-continent rift locations in the UP. Now, we all know there's two Montreal rivers in the UP. This is the one on the west, Wisconsin, border with Wisconsin. And here I am confusing you again, because this way's north, and here, that way's north. So you can see you have your sandstone, shale, sandstone. This is the top of the Freda Formation right here. And it's on something called the Montreal monocline. And once again, I failed you, and I put it north this way. So, yeah, sorry about that. So here's the outcrop, basically. This has no vertical exaggeration to it. And none such. If you go far enough south on this river, you will get into the volcanics. Okay, now we're going to move just a tiny bit east to Black River. And this is, I redefined the Copper Harbor conglomerate in, I think, 2018. I added a few members to it. Now, this is the type section for most of that. Here's the basal member of the Copper Harbor, which is the, what did I call it? Oh man, sorry. What did I call it? Not Gorge Falls. Great Conglomerate Falls, remember. That's the bottom. It has the biggest class in it. Then you get the Potawatomi flows. These are not part of the Lakeshore Traps. They're not considered part of that. Lakeshore Traps is an informal term. That's in lithostratigraphy. You can't call something that. That's not something you can use. So this is a little bit older than that. And they're mostly what we call felsic rocks. They're not mafic, so they're not basalts. They're more like andesites and rhyolites. Just this one little area they are along the falls, and that's the only place they are. And here, this is what I call sandstone falls member. This is the third member from the bottom. And here you got a lot of alluvial fan deposits with some sandstone. You see a lot of cross bedding. You get beautiful ripple marks on some of this stuff. This is at Sandstone Falls. So you guys may have seen this stuff if you go over there. Now we're gonna go Porcupine Mountains. This is a very simplified geologic map of the porcupines. This is in the book. It's based off Cannon's a little bit, except Cannon is not a structural geologist, so he has this funky fault thing going on here, which is not physically possible, so I fixed it for him. So this makes more sense and fits the field data better. So you have a little syncline here, Presque Isle syncline, another Presque Isle. How many of those have got a UP3? I think, something like that. So here's the river. And here's it in cross section. The Porcupine Mountains are a volcano on the rift. That's what they are. That's why these alternating layers. And this is at Presque Isle. This is the Nonsuch, and here you have these big pillow balls. These are not lava. This is not lava. This is a siltstone, a mudstone. Nonsuch. We think these massive things formed through tectonic activity, just earthquakes. We still had them going on. And there is an angular unconformity between the Nonsuch and the Frida there, too. And so in this area, at least, the Nonsuch right here had to be high and dry or wasn't preserved or whatever. We just had non-deposition, but this is angular. I've measured it. These beds are nearly horizontal, and these are not. So the Frida Formation has angular unconformity right on top of the Nonsuch. It's clear as day there. Usually these two grade into one another. And this, everybody knows this. This is my photo, but everybody's taking a picture of this. This is all basalts and rhyolites of that volcano. Now the upper member of the Copper Harbor is the Union Bay member, and this is at Union Bay. You get these little bit of pebbles in it. It's mostly sandstone. It actually looks a lot like the Frida in places. And I'm walking through there, and I mean, this isn't true, but it's not far from the truth. I can't tell a trilobite from a brachiopod, okay? Because I don't study those. But these do not look like mud cracks to me. So I'm not wondering if these are some sort of algae mats or what, because this is supposedly before macrolife evolved on Earth. These rocks, 1.087 billion years old, so 1,087 million years old. And I'm going to go way up here, closer to the good stuff. The Oronto group, that's the Copper Harbor and stuff. This right here you have the Nonsuch, and here the Nonsuch with the Frida is not an unconformity, it intertongues. And then so I'm working on the Frida right now, so I've been all up and down here, and in Wisconsin too. The Nonsuch is exposed, as is the overlying Frida. So, and I know I'm focusing on the sedimentary rocks because that's what I study, but many of you might know where this is. It's Eagle River. This is not a fault contact. This is just a depositional contact. You got the volcanics here in the very base of the Copper Harbor here, which locally is a pure sandstone. You don't get a conglomerate until higher up. So I named this the Garden City lens when I redefined the whole thing because I could trace it. But the conglomerate does start. So usually conglomerate lies right on top of this, but just here it doesn't. It's more sandstone. And there's a person for scale down there. And that's what it looks like in, I think that's November, I think that was. Oh. Now we're on the other side of the Keweenaw Fault, kind of. We're actually at it here. Haven Falls Park, you guys know where that is? That's a fault scarp right there. And this is what it looks like in November. So, and you do see slip inside and stuff like that. Now I'm gonna treat you to something here that's not in the book because it's private property. Many of you may have been there anyway. I think it's here. Yeah, it's not that far from there. And this is why you gotta be careful. What's this look like to you? Right there. A wall. It looks like a wall, right? It's not a wall. I'm not trying to set anyone up, but that's what, if I just saw this picture thrown in, that's why I'd say, oh, that's a wall, It's not. This is it from the side. That's shale, this is sandstone. So it's just been turned due to the faulting almost vertical. And this is the other side of it where you can really see the ripple marks of the sandstone on it. This is natural. I know when you go through school you're told rocks don't break in nice angles, but they do. They do. So that's all this is fracturing and jointing. Not really, I lied, it's Greenland time. So that was your just crash course summary in the Mid-Continent Rift. I hope it was useful. Try not to.
Question.
Yeah.
That vertical, semi-vertical wall.
Yeah.
Essentially, the shale was eroded away because it's more easily weathered.
Mm-hmm.
And even the sandstone that's more durable.
Yep. Yep. But it's only right there. I don't know why. Now, I do know there used to be a rail line through there a long, long time. I don't know if they might have knocked some down to clear, 100 years ago, or what was going on. I don't know. But this
I have
is.
a postcard of that, and it looks pretty much the same as what Trip did.
Oh yeah, it's on. I mean, the guy was nice enough. I forget his name. I feel like such a jerk. But he let me on there because I know Michigan Tech goes out there a lot too. And I just didn't put it in the book because I didn't want people walking around on his property.
Steve.
So.
Steve. Got 5 minutes.
Oh, okay. So we're at the stretch. This is us flying over into Greenland. And despite what you hear, Greenland is green, at least in the summer. You landed at Nuuk. You cannot fly directly into Greenland as of now. Hopefully, for the next couple of years, that will change. They just bought an Airbus. They extended the runway. So you have to go to either Iceland or Denmark, then fly to Greenland. We went to Iceland, and the person that wrote the book with me, she teaches at the University of Reykjavik now. So we just stayed with her. Then we went to Greenland. And it's funny because we went from Iceland to Greenland. We're like, do you guys need our passports or anything? They're like, no. Because all the Nordic countries and those, they are all just let everyone go wherever. No one cares. So it's nice. That was behind our hotel, so of course I had to look at that. And this is just this is just cool rock pics more than anything. I'm not going to do too much detail on this. It's just cool rock. I will be writing a book about our trip. It'll be a geology, and it's just kind of going to be like our experiences, and then of course I got to throw geology in. So it's not going to be like my roadside books. This is for the plane too, over the main ice sheet. Check 2 of them. Now you can see a lot of little lakes. Little lakes there. Here's us on a boat because that's how everyone gets around. And you know what? You really don't know how populated the planet is until you go to a place like this. I mean, there's no one out there. Were there like 20 sheep for every person? And we stayed at a sheep farm the first time. This is more of that sandstone. Oh, how'd that get in there? Oh, look, there's a fat guy walking with a cat. Look who that is. Sorry, it's that. This was the local kitty. She just followed me around. And we stayed at the cabins, the boat. And here's again. I promise that's the last one. So this is us walking up the hill to look at the Locogen, the rocks of the Locogen. There's Sarah, and you just look out. And there's not a lot of trees. There is some forest. We were just north of the forests, but they are trying to replant some forest. I don't have any pictures of it. I failed. But as we were walking to our second place, you could see it. But, I mean, there is grass and stuff here. What is that? What's that trying to do that? So, and there's sheep. You'll be walking out in the middle of nowhere. You look kilometers around. There's no one. There's no buildings. There's no people. There's no roads. And you just all quiet, and all of a sudden you look up and bah, right at you. I had one that she thought what the lady said is she probably thought I did something with her babies because she kept screaming at me and running at me, following me around. I thought, "Get your kids." This is just out into the fjord. That is sea level. There's Sarah and her friend Rachel. So this is a lake on top of the mountain. It's looking back down at the fjord, and that's Leif Erikson there. This is a little north of where we stayed. I didn't know this until we got there, but we actually don't know if the Europeans landed first or if the natives came first, or they got along. There doesn't seem to be anything, no conflict or anything. And it looks like a volcano, doesn't it? It's not. There's no volcanoes here. It's a cirque. And this is a glacier they boated us up to. And here we're still, like a couple miles away at this point. And this thing was massive. And Sarah's awesome camera as opposed to my not so awesome one. She got the glacier by zooming in. These are some ruins, Nordic ruins. And that's just the moon up on I just thought that was cool. This is the last place we stayed that we had to walk to. And yeah, lots of sheep there too. This actually was a town. The first place we stayed at wasn't. A lot of colorful buildings. That's it. That's it. I swear. Nothing else. Any questions? Sorry, I promised 45 minutes. I'm talking really fast. Yeah.
What about mineralization associated with the content drift? Is that
good question.
Like the Eagle Mine and others, some of the other proposed sulfide mines, are those associated with the Mid-Continent Rift?
Yes, I believe so. I believe the Eagle Mine is too, but she would know better probably than I would. I know more about, copper country when it comes to the mines. And what's really unusual about copper country is, you usually find gold, silver, and copper together. But for some reason, it's almost all copper with a little bit of silver in places. There's no gold. The gold is all in the greenstone belts, as far as I'm aware. So, yeah, so that's really weird too. That's really weird. At least that's how it is on the west side of the Keweenaw Fault. Any other questions? Yeah.
Still copies of your book here, Reggie.
Yeah, and I sold them already because I did not think ahead. If you guys want, it is available on Amazon. It's $38.
Signed.
No.
What?
No.
Excuse you, Lou. Jack, there were.
I should have brought more. I wasn't expecting this many people here.
Yeah, George got one, Jack got one.
Yeah,
Yeah.
You need more of an ego.
I know. I do. I don't really.
We can always meet you for lunch and bring you more.
Yeah. Yeah. You want to go to Peterson's Fish?
Yeah, we'll
Fish
meet at
Okay.
Peterson's and
Yeah.
you can bring me more copies and the Ishpeming Rock and Mural Club will have a huge
Any more
song.
other questions?
Or maybe we'll
Any others questions? Oh wait, I think I have a marked up copy of the book here so you can at least know what it looks like. No, I don't? Oh, it's in the car, isn't it?
George, you want to hold up your book?
Yeah,
You got your
they
book?
can look at it.
Everybody can see what it looks like? There you go, that's
Yeah.
what it looks like.
This is actually the second edition. It's the only one available right now. First one's not available. This has a lot more sites in it. I do plan on doing a third edition probably by 2025. I have to take one site out because it switched owners. And I do have a couple others I want to add. So, but that does come in hardcover too, but it's like $55. So I think I've sold 2 hardcovers, and that's it. So I don't even bring hardcovers with me. So yeah. Oh no, what did it do? Okay, so if there's no other questions,
I got a question. When
Yeah.
you calculate all this information, this rifts and all this stuff, and who was right? I mean, it's all hypothesis. I mean,
no, we're pretty confident it's a rift. Yeah, failed rift.
I mean, about how long everything moved around, Benji and all that, millions of years ago. I mean,
Because we can make accurate testable predictions. That's how science works. Science doesn't ever actually seek absolute truth. That's not something it worries about.
Yeah.
It worries about what's testable. We use words like truth and proof, but we mean them generically. And we never prove anything in science. We disprove things. That's what we do. We falsify things. And there's some new stuff coming out around the area about the UP too. And like Baraboo in Wisconsin, I co-authored a paper with an old professor of mine on that. It seems that we pulled zircons from that quartzite and we got source areas that have to be from like northwestern Canada, which means that sandstone sheet had to be much larger. So, because they're that old. So, but it's just our best guesses and what we can show. That's really all it is. Yeah, so, so. Do we know exactly what Pangea looked like? No. Do we have a pretty good estimate? Yeah, I think we do. So, do we know what'll happen in the future? 50 million years from now with the continents? Probably. We probably got that down. 300 million? You don't really know. You start going too far into the future and you start losing things. Of course, you go too far into the past, looking at the rocks. Fortunately, we have so many, because Marquette is one of the few places on Earth you can see 3 billion years of geologic time within city limits. Really, people think they need to go to Australia or Greenland or places exotic like that to see stuff. But there's so much right here and just across the border that are really good. One more question, then Bev's gonna probably shoot me if I. Okay.
It's really stupid.
No, there's no stupid questions.
Could you talk about your credentials a little bit?
Yeah, okay.
Are you a patient or are you an application?
I am. Michigan doesn't have these, but I'm a licensed professional geologist in Illinois and Indiana, but I do most of my stuff up here. I got my bachelor's at ISU. I got my professional license, and I have an honorary master's from ISU.
That's Indiana State?
No, Illinois State.
Illinois State.
Actually, Illinois State, if you go for geology in the Midwest, there's two places you want to go.
Yeah.
You want to go to Illinois, or you want to go to Wisconsin.
Or
Those are
Michigan
really-
Tech.
Well, not for field camp, I don't
Okay,
think. For
okay,
field
all right.
camp, it's ISU or Wisconsin.
Okay, all
I
right,
think.
okay.
I've written papers. I am living proof you don't have to have a PhD to write papers. I have 2 where I'm the primary author, and I think I have 2 or 3 more where I'm co-author on. And I said I'm going to do the Frida Sandstone here too. So, yeah, that's me in a nutshell. So I unfortunately work for private industry now. So I worked for the government for a long time. So yeah, that's it.
Tell them where you publish.
What?
Tell them where you've been publishing.
Where you've been publishing?
Terra, Nova, Journal of Stratigraphy. There's one in, of course you would have to ask that, wouldn't you?
Thought you might want to know.
My memory sucks and I don't have notes. Yeah.
We trust you.
So, yeah, you can look me up online. I'm there. I don't hide anything. So,
Long walk on the beaches.
we did that today.
Yeah.
Nice rocky beaches. And no, I should have put some pictures of the aurora from last Labor Day in there because that was beautiful. And I also failed you, and I'm just going to tell you this because I'm going to tell you this, but you know how you have the Uber lights?
Yeah.
Well, there's, where we were in Greenland, there's rocks similar to that because those come from the Coldwell complex in Ontario. That's where they come from. There are big, huge intrusions that just make the Uber lights look sad. I mean, you hit that with it, and the whole rock is like, boom.
Wow, cool.
And I have some of those, but I failed to bring them. 'Cause I forgot. But,
If you have a little extra one, the club would love to have one for our fluorescent display.
I can cut you off a piece
There
from
you go.
one.
That's
and
probably
send it to
finding
you.
somebody who can cut off a piece.
Yeah, cut it because we don't have that. Anyway,
All right.
okay, I'll stop because Bevel.
No, I'm happy to have you, Steve. Thank you for coming. Steve, you still live in northern Indiana and in Keweenaw in the summer? Is that where your primary residence still in northern Indiana?
It's in northern Indiana.
Okay.
My mother lives in Morium.
Okay, yeah.
Um,
And you have a cottage somewhere in the Keweenaw?
oh yeah, we have a
Okay, okay.
West of Calumet.
Yeah, yeah.
So we're up here a lot.
Yeah.
So the plan is to hopefully in the next couple of years permanently.
Steve recently had a major loss in his family, so he made sure he was here before he has to head back to Indiana for a funeral. So anyway, we are so grateful you came even after that loss. Thank you so much.
The funeral's not till Monday. There's not much I can do at this point.
Okay, but thank you for coming, because a lot of people might have canceled, and we really appreciate
No,
it.
I said I would.
Thank you.
Try to.
Thank you.
If you guys, I love talking to you guys. And if you ever need me again, I'll be more than happy to.
Thank you.
Let
Thank
me
you
get
so
out of
much
here.
for coming.